Communicating Expectations. On September 4th, 1904, an article entitled Berlin's Wonderful Horse, He Can Do Almost Anything But Talk, was published in the New York Times. The wonderful horse was a German stallion named Hans, later known as Clever Hans. Hans's owner, Wilhelm von Onster, was a schoolteacher who, upon retirement, decided to teach a horse math and German. Von Onster believed that by using the same techniques he had mastered in the classroom, he would be able to communicate with anyone. Even a horse. For 4 years, von Osten stood in front of a blackboard and taught Hans how to read, spell, do arithmetic, name the date, tell time, and much more. Hans would use his right foot to answer questions. In response to complicated math problems, for example, Hans would respond by tapping his foot the number of times that responded to the correct answer. He created words by using a similar system. Von Osten had the alphabet written out on the blackboard, and Hans used a specific tapping sequence to indicate each letter. Hans could recognize people and spell out their names using the correct spellings of the complicated German language. Experts and laymen alike were impressed. The New York Times made clear that the facts in this article are not from imagination, but are based on true observations that can be verified by scientific and military authorities. Could a horse really add, multiply, and tell the exact hour and spell? Or was he simply taught some clever tricks? Some of those who used to train or to perform animals in the circus, people everywhere were intrigued and wanted an answer. Did Hans really possess incredible mental powers? On October 2nd, 1904, almost a month after publishing the original story, the New York Times came out with a follow-up of the piece. Clever Hans again. Expert commission decides that the horse actually reasons. The commission, comprised of doctors, zoologists, physiologists, and circus trainers, was unanimous in their opinion. Hans had not been taught a fancy circus tricks. He had been trained by the same methods used to educate school children. He seemed to have genuine mental abilities. Hans could give correct answers even if his master was not the one asking the questions, and he could even answer questions about subjects he had not been taught by his trainer. And so, the conclusion that if animals were to be treated as humans, they would think like humans too. The commission passed its findings to the psychologist, Oskar Pfungst, however, was not convinced. He decided to examine the genius horse himself. Pfungst's careful investigation revealed the horse could answer almost any question correctly as long as A, the questioner, knew the answer himself, and B, the horse could see the person asking the question. When those two conditions were met, Hans got 89% of the questions right. However, when one or both of the conditions failed to be fulfilled, Hans' ability to answer questions dropped to a mere 16%. What was going on? What Pfungst concluded was that Hans was actually responding to unconscious bodily cues from the questioner. The horse would be asked a question and then start tapping away. When the number of taps approached the correct answer, the questioner involuntarily tensed his body and facial expression in expectation. When Hans delivered the last expected tap, the questioner would change his posture and facial expression again, releasing tension. That was Hans' cues to stop tapping, and so he did. In other words, Hans did not know the answer to the questions. He was not performing complicated math tasks. He did not know if it was January or December, Monday or Thursday. In 4 years of tedious training, what Hans had learned was how to respond to his master's bodily cues in a way that made his master happy. For a stallion, that is not an accomplishment to be dismissed. Because von Osten believed he could teach Hans language and math and thought that he could teach his horse to give correct answers to verbal questions, his expectations had an impact on the horse. True, Hans had not been performing the task the way his master thought he was. The horse was not retrieving the information von Osten had taught him. Rather, Hans had been unknowingly conditioned to stop tapping in response to certain bodily movements of the person in front of him, yet the end result was the same. The stallion was providing the right answers, the answers von Osten expected him to provide. When it comes to humans, the influence was socially communicated. Expectations run deeper. In the late 1960s, a collaboration between the Harvard psychologist Robert Rosenthal and the principal of the elementary school in San Francisco, Lenore Jacobson, led a fascinating demonstration of the self-fulfilling prophecy. The two wanted to examine how teachers' expectations affect their students' performance. Could students' achievements be modulated by the teachers' preconceptions even when those were based on nothing at all? Rosenthal and Jacobson randomly selected students in Jacobson's school and told their students that those children were found to be at a point of significant intellectual growth. This information was false. There was no data indicating that the abilities of those students were different from those of any other students. Nevertheless, at the end of the year, the sham predictions had become reality. The students who had been singled out at random by Rosenthal and Jacobson had intellectually superior, scored higher at the end of the year IQ tests, and the students who had scored similarly at the beginning of the year, their improvement throughout the year was greater than what it would have been normally expected. Like the Magic Johnson, Kareem Abdul-Jabbar, the stallion Clever Hans, the students delivered what was expected of them. The conclusion was clear. Humans are hugely affected by the expectations placed upon them. Your employee will be more productive if you expect him to be. Your spouse will be more loving if you anticipate her to be. Your child will be more likely to do well in school and sports if you believe he is talented, and less likely to do well if you hold negative expectations regarding his ability. Even teenagers, alcohol consumption has been shown to be influenced by parental expectations. What exactly did Jacobson's teachers do that resulted in the observed enhancement of the academic ability of the students? Rosenthal identified a number of behaviors expressed by the teachers that could have been influenced by the children's performance. The teachers spent more time with the talented students than with the other students, provided them with more detailed feedback, and were more likely to encourage them to respond in class. Overall, the teachers treated the quote-unquote special kids differently, and as a result, those kids indeed became special. Rosenthal and Jacobson referred to their findings as the Pygmalion effect. After George Bernard Shaw's play, Shaw's Pygmalion is a classic makeover tale, the story of a professor who transformed into a working-class girl into an upper-class lady. At Rosenthal's and Jacobson's Pygmalion study, pre-existing notions were assigned to the children at random in real life. However, educators, as well as the rest of us, hold relatively stable preconceptions that are in general not based on real evidence. Teachers have shown to form predictions regarding new students' achievements based on race, gender, ethnicity, social-economic level, and even physical attractiveness. This can be dangerous. Expectations, as we have just learned, are likely to influence a child's performance, ultimately altering his future. In fact, the Pygmalion effect is thought to be a significant factor in producing and maintaining gender and racial gaps in IQ testing, GPS, and college success. The power of stereotypes. Stereotypes are just another example of self-fulfilling prophecy. They're especially powerful in shaping an individual's reality, particularly when it comes to expectations are held by a large number of people. people who conform to their group stereotypes because society interacts with an individual in a way that is consistent with the stereotype-based prediction. Take Tom and Rob, for example. Both are students in an elementary school in Washington, D.C. They are about the same height and the same weight. And both are average students, and both are well liked by their peers and teachers. Tom is black and Rob is white. Initially, Tom and Rob possessed similar physical abilities. Rob could run as fast as Tom, could jump as far, and was just as prone to shoot the ball into the basket. Everyone, however, expected Tom to be a better basketball player than Rob, simply because of the color of his skin. For that reason, Tom was more likely than Rob to be selected to play on the basketball team by his peers. His coach took special notice to making sure to correct his game. Tom's parents encouraged him to train extra hours on the court after school. As a result, Tom actually became a better player than Rob. Although the belief that Tom was better player than Rob was false to begin with, the stereotype began self-fulfilling. Consequently, Tom is another example of the stereotype that blacks are better at basketball, strengthening the misconception that essentially feeds on itself. Stereotypes nourish themselves not only because they affect the way people act toward the individual being stereotyped, but also because individuals have a strong tendency to be rapidly conform to what is anticipated of them. The most astonishing example of such rapid fulfillment of expectations is the famous case of Jane Elliott, a third-grade teacher in Iowa. Her class, like most of those in the state of Iowa, was composed solely of white students. On April 5, 1968, the day after the assassination of Martin Luther King Jr., and Elliott wanted to demonstrate to her students how it feels to be racially discriminated against. She came up with a game. As a part of this game, the kids were to be separated into two groups according to the color of their eyes. Elliott announced that blue-eyed children were inferior to brown-eyed children. She said they were less intelligent, slow learners, and were therefore to be treated differently. Blue-eyed children could break for recess only after the brown-eyed kids had left the class. Furthermore, they were not allowed to communicate with their superior brown-eyed kids. Immediately following Elliott's announcement, the kids' behavior changed. Brown-eyed children became more confident, while blue-eyed kids became frightened. More astonishing was the sudden change in the kids' reading and writing abilities. Elliott observed abrupt improvements in the abilities of brown-eyed kids and a decline in the abilities of the blue-eyed children. The next day, Elliott reversed the roles. Now blue-eyed kids were proclaimed superior to brown-eyed kids. Within minutes, the children adapted to their new roles. Blue-eyed kids were now acting dominant, while the brown-eyed kids were acting scared and frustrated. A spell test that Elliott conducted on both days revealed that the children did better on the days their group was declared superior. Jane Elliott's students were responding to expectations that were explicitly expressed by an authority figure. When told they were stupid, they immediately acted stupid. When told they were smart, they acted smart. One might argue this was because children are actually suggestible. Surely adults with well-developed self-image would not be as gullible, or would they? Not only do adults rapidly conform to expectations in manner similar to that of Elliott's students, they do so even when they are not consciously aware of what is expected of them. My colleague, Dr. Sarah Begtison, a cognitive neuroscientist, wanted to see if she could influence performance on a cognitive task by priming college students with words such as smart, intelligent, and clever, or words such as dumb, stupid, and daft. After presenting the participants with a word such as clever or words such as stupid, she asked them to complete a variety of cognitive tests. She found the students performed better after being primed with the word clever than when given the word stupid. Begtison could influence people's expectations of their own performance of a task simply by presenting them with information that was irrelevant to their true ability. Nevertheless, this irrelevant information unconsciously modulated people's expectations of themselves and thus changed their performance. In a similar manner, when individuals are reminded of their membership to a group such as gender or race, the stereotype associated with the group is more likely to influence their behavior. For example, females have been shown to score lower on math tests when reminded of their gender before the test. Reminding females of their gender unconsciously activates the stereotype that women do not do well in math. This priming lowers females' expectations of their ability to do well on the exam, causing them to accept the stereotype and do worse. In another example, African Americans were found to do significantly worse on IQ-type tests compared to Caucasians when race was emphasized, but they did well as well as Caucasians when no stereotype threat was present. What Sarah Bengenstone's study shows, as well as Jane Elliott's field experiment, is that influence of stereotypes and surprisingly fluid new expectations can rapidly take over old ones, quickly subsiding one behavior for another. This fluidity is encouraging. It means with guided intervention, we may be able to reverse the negative effects of stereotyping an individual's performance. How many more pages? Yeah. Learning from failed predictions. How do expectations influence the workings of the human mind? Bengenstone's study provided some intriguing answers. She conducted her clever/stupid priming study on volunteers while their brains were scanned in functional magnetic resonance imaging (fMRI) scanner. An fMRI machine not only shows an anatomical image of the brain, it provides data that can tell us how the brain functions. When neurons in a specific part of the brain are active, their consumption of oxygen is increased. In response, blood flow will be enhanced to that region, supplying hemoglobin to the oxygen storage molecule that releases and absorbs oxygen. This leads to local changes in the concentration of the deoxyhemoglobin and the oxyhemoglobin, which alters the MRI signal that is recorded by the scanner. So if a subject lies in an fMRI scanner and listens to Rachmaninoff's Piano Concert No. 2 and the Black Eyed Peas or Al Green, the scanner will record changes in the blood oxygen level dependent BOLD or BOLD signal from the auditory cortex, indicating that activity in that part of the brain is enhanced when listening to music. What Bengenstone's data showed was the participants' brains responded differently when they learned that they had made a mistake, according to whether they had previously been primed with the word clever or with the word stupid. When participants were primed with the word clever and then made an error, enhanced activity was found in the medial prefrontal cortex. This heightened activity was not seen after people gave a correct answer. Neither was it observed when they previously had primed with the word stupid. The frontal cortex is a large area of the brain that includes anatomically and functionally distinct subregions. It is the most recently developed part of the brain and is not found in animals at the lower end of the evolutionary scale. Although many non-human animals have frontal lobes, theirs are considered less developed than the frontal lobes of humans. The frontal cortex has enlarged disproportionately in human evolution relative to the rest of the brain. Its physical development is the main reason why we have relatively larger brain than most other animals.